This is lesson 4.3, congruent triangles, starting on page 258. For number 1, show the polygons are congruent by identifying all congruent corresponding parts, then write a congruent statement. So, for number 1, we have angle Y, which is congruent to angle S, since they have the same marking. And angle X is congruent to angle R. And we have angle XZY is congruent to, in the same corresponding order, RZS. Okay, we also have congruent corresponding sides. So YX and SR are marked the same way. Likewise, XZ and RZ and YZ and SZ. Then we want a congruent statement. So since all corresponding parts are congruent, we can say that triangle YXZ, and we must go in the same corresponding order for the other triangles. So YXZ is congruent to SRZ. Okay, on number 3, Sarita is changing the tire on her bike in the nut. Securing the tire looks like the one shown here. Which of the sockets below should she use with her wrench to remove the tire? Explain her reasoning. So it's very plain to see that she would use the 1/2-inch socket. And for an explanation, we could say that the socket is congruent to the nut. So the socket is congruent to the nut, therefore this socket would fit on that nut. In the figure, triangle LMN is congruent to triangle QRS. For number 5, we want to find the value of Y. So the expression here, Y plus 10, is for angle M. So that is the second letter in the name, so we want the second letter in the name here. So angle M is congruent to angle R. So if we look at angle R here, we have this expression. Therefore, if those two are congruent, we can set those two equal. So we have Y plus 10 is equal to 2Y minus 40. And we're solving for Y. So subtract Y from both sides. And add 40 to both sides. So Y is equal to 50. For number 7, find X, explain your reasoning. So in our triangle here, we have an expression 4X for angle X. So angle X of this triangle would be congruent to angle N of this triangle because that's the unmarked angle in both of those. So first we would have to use the angle sum theorem to find the measure of angle N, so we have something to set 4X equal to. So the three angles of any triangle must add up to 180, so 65 plus 51 would be 116. So if we subtract 116 from 180, that leaves us with 64. So 64 is the measure of angle N. And since N is congruent to X, we could set 4X equal to the measure of angle N. And divide both sides by 4, and X is equal to 16. For our explanation to this, we could say that n corresponds to x, and n will be congruent to x by the third angle's theorem. Since we have two pair of corresponding angles congruent, then the third angle is congruent. So by the third angle's theorem, angle n is congruent to angle x, where angle n is equal to 64, and therefore 4x is equal to 64. So something like that. For number 9, show that polygons are congruent by identifying all congruent corresponding parts, then write a congruent statement. So we have angle x is congruent to, in this triangle, the other right angle, angle A. Angle y is congruent to, in this triangle, 60 degrees, angle B. And angle z is congruent to the 30-degree angle here, angle C. We also have our corresponding sides. So we have xy is congruent to, so that goes from right angle to 60-degree angle. So from right angle to 60-degree angle here, that would be side AB. We have yz and that goes from 60 to 30, so from 60 to 30 that would be BC. And then zx. And in the same corresponding order, that would be CA. So we've identified all the congruent corresponding parts. Now we want to write a congruent statement. So triangle XYZ is congruent to triangle in the same corresponding order. So we have right angle, 60-degree angle, 30-degree angle. So right angle, 60-degree angle, 30-degree angle would be ABC. Likewise for number 11. So the markings here are the same, here are the same, and there are the same. So angle R is congruent to angle J, angle T is congruent to angle K, and the angle S is congruent to angle L. Likewise, corresponding sides, put them in the same order. So if you go from 1 mark to 3 marks, we want to make sure to go from 1 mark to 3 marks there. So angle R, or side RS, is congruent to JL. ST would be congruent to, so 3 marks to 2 marks, LK. And so we have RS, ST, so we also want TR. So that's 2 marks, 1 mark. So 2 marks, 1 mark, so KJ. And then our congruent statement. So triangle RST is congruent to triangle in the same corresponding order. So 1 mark, 3 mark, 2 marks, 1 mark, 3 mark, 3 marks, 2 marks, JLK. For number 13, polygon BCDE is congruent to polygon RSTU. Find each value. So for number 13, if we want to find x, we have an expression here that has x in it. So 2x plus 9, and that's the measure of angle B. So angle B is the first letter in the name, So the first letter in the other polygon's name would be R. So angle B, the measure of angle B is equal to the measure of angle R. So the measure of B is 2x plus 9, and the measure of R is 49. So we would subtract 9 from both sides, and 2x is equal to 40, and we would divide both sides by 2, and x is equal to 20. For number 15, we want to find the value of z, so we have an expression with z in it here, so that is side ED. So ED would be equal to, so that's the last letter, then the third letter, so the last letter and third letter would be UT in that order. So ED is 3z plus 10, and UT is z plus 16. So now we want to get z on the same side, so if I subtract z from both sides, I would get 2z plus 10 is equal to 16. So next I would subtract 10 from both sides, and 2z is equal to 6, and divide both sides by 2, and z is equal to 3. On number 19, we would use the third angles theorem, which says that if two pair of corresponding angles are congruent, then the third pair of corresponding angles will be congruent. So we know that these two angles are congruent, so this is 148 and this is 148. We know that this angle is marked the same as this angle, so those two angles are congruent. Therefore, we can assume that this angle is congruent to this angle. So we know that 5x minus y is equal to 18. And we need to get another equation here, so we know that 3x plus y is equal to this angle. So we need to figure out what this angle measure is, so add these two angles together. And that would be 166, and we want to subtract that from 180, and so we get 14. So we know that this angle measure is 14 degrees, and that angle is equal in measure to this angle. So 3x plus y is equal to 14. So we end up with a system of equations here with two variables, two equations. So we can use substitution. We can solve this equation for y, subtract 3x from both sides, and y is equal to 14 minus 3x. Now we can substitute 14 minus 3x in place of y in this other equation. So now we would have 5x minus y, where y is 14 minus 3x equals 18. So if we distribute the negative sign, we have minus 14 and plus 3x. If we combine our like terms, 5x and 3x gives us 8x. If we add 14 to both sides, we would get 8x is equal to 32. And if we divide both sides by 8, we get x is equal to 4. Now that we know what x is equal to, we can substitute 4 in place of x into this equation to get y. So y is equal to 14 minus 3x, where x is 4. So that would give us 14 minus 12, or y equals 2. Okay, number 21 asks for a two-column proof of the the third angles theorem. So in other words, if angle A is congruent to D and B is congruent to E, then angle C will be congruent to angle F. So that's the third angles theorem. If two pair of corresponding angles are congruent, then the third pair will be congruent. So we'll start by stating our given information. And anytime angles are congruent, we can say that their measures are equal by the definition of congruent angles. We can also say that these three angles must add up to 180, and these three angles must add up to 180, and that's by the triangle angle sum theorem. Three angles of any triangle must equal 180. The triangle angle sum theorem. So from here, since they're both equal to 180, I can rewrite this statement, but in place of 180, I could put the measure of angle DEF, or the measure of angle D plus the measure of angle E plus the measure of angle F, since it's also equal to 180. So I can substitute this in place of the 180. And from here, since I know that A is equal to D, I can substitute D in place of A. And since I know that B is equal to E, I can substitute E in place of B in this statement. So substitution for that one as well. And then from here, since I have the measure of angle D plus the measure of angle E on both sides, I can subtract it from both sides. So I'm just left with the measure of angle C on the left and the measure of angle F on the right. So that is the subtraction property of equality. And finally, if two angles have the same measure, then we say that those two angles are congruent by the definition of congruent angles. For number 23, we're given that BD bisects angle B and that BD is perpendicular to AC, and we want to prove that angle A is congruent to angle C. So let's start by stating our given information. And since BD bisects angle B, then that means that these two angles will be congruent by the definition of an angle bisector. An angle bisector splits an angle into two congruent angles. So, angle ABD is congruent to angle CBD. And that's by definition of angle bisector. We can also say that angles ADB and CDB are right angles by the definition of perpendicular lines. Since these two lines are perpendicular, then they form right angles. So the definition of perpendicular lines. And of course, if they're both right angles, then they'll be congruent because all right angles are congruent. And now we have a pair of angles here congruent, a pair of angles there congruent. So then by the third angles theorem, we can say that the third pair of angles will be congruent. So third angles theorem, A is congruent to angle C. For number 27, we want to prove the reflexive property of triangle congruence. So basically, given a triangle, we want to prove that it will be congruent to itself. So we are given a triangle, DEF in this case. Therefore, the segments or the sides will all be congruent to themselves because congruence of segments is reflexive. So DE is congruent to DE, FE is congruent to FE, DF is congruent to DF. Likewise, congruence of angles is reflexive. So we can say that angle D is congruent to angle D, E is congruent to E, F is congruent to F. So by the definition of congruent triangles, all the corresponding parts are congruent. So all the sides are congruent, all the angles are congruent. So we can say that triangle DEF is congruent to triangle DEF by the definition of congruent triangles. For 29, we want to draw and label a figure to represent the congruent triangles, then find x and y. So I've drawn two triangles here, and I put them in the same corresponding order so that the parts line up. So L is the first letter, R is the first letter, M is the second letter up here, S is the second letter up here, N is down here, so T is down there. Then I labeled everything. So L is 49, M is 10y, S is 70, and T is 4x plus 9. So from here, I can set up some equations to solve for my variables. So I know that M is congruent to S, so I can set 10y equal to 70 and divide both sides by 10, and I get y is equal to 7. To find x, we need to know what n is equal to. So if m is equal to 70, so I've got 70 degrees for m, L is 49. If I add these two together and subtract from 180, I'll have the measure of angle n. So 70 plus 49 would be 119. And if I subtract that from 180, I end up with 61. So n has to be 61 degrees, and I set 61 equal to t, 4x plus 9. So I would subtract 9 from both sides. So I get 52 is equal to 4x, and I divide both sides by 4. And x is equal to 13.